Hello, and welcome to This Old Math Class. I'm your host, Bruce the Toolman Corrigan-Salter. Today on This Old Math Class, we're going to be building an easel to display art. And in order to build this easel, we're going to have to use some mathematics. The issue is that when I build an easel, two of the pieces of wood are going to come together, but they're going to join a third piece of wood and they have to come in at an angle. Now the question is, what angle am I going to be using right here in this cut so that I can properly cut this piece of wood and allow it to make that easel? Now it turns out if I build an easel, it's really going to be based on a triangle, and I can use the information that I know about triangles to calculate the angle at which I need to make that cut. Once I calculate that angle, then I can use my handy dandy protractor to draw that correct angle on the piece of wood, and then I can cut along that line. After that, I can actually assemble the easel. So that's what we're going to be doing today. We're going to be building an easel using some mathematics, and then talking about the mathematics that can go into building anything out of wood that involves triangles. So what we need to do now is figure out our plan for the easel, the information that we know about how big we want it to be, find a triangle in that drawing, and use that triangle to calculate information that we need. And now sometimes that information that comes to us will be information that we already know. So for example, this easel, I happen to know how big I want it to be. I want it to be 8.5 by 11. I want it to hold a print that's 8.5 by 11. And using that information about the length and the fact that I'm using wood that is, it's 3/4 inches by 1 inch, knowing that I have that piece of wood that I'm going to be using, I can use that information when I'm actually trying to figure out the angle that I'm going to be making the cut at. In other situations, we may know the angle that we want. Maybe we want it to be 45 degrees, and what we don't know is the length. And in times like those, what we'll have to do is we will have to take the information about the angle, again, find a triangle inside our diagram or our drawing of what we want to build, and then use that information about that angle to figure out the length of the piece of wood that we'll be cutting. So we're going to go to the drawing board now and take a look at how do we use math to figure out how big something should be. Okay, so I brought you into the math shop, not the workshop anymore, but the math shop where we can try to figure out how to actually determine what angle we need to make those cuts at. So right here I've got a picture of this is the easel that we're trying to make, and what we should notice is that what I'm really trying to figure out essentially is what this angle is right here. So this angle that I've colored in red. And in order to do that, I need some information about the triangle. And then I need some information that I can actually calculate using mathematics. So if you recall, one of the things that I said I wanted to do was I wanted to make it so that it would fit in an 8.5 by 11 sheet of paper. Now I know that the wood that I'm working with is about 3/4 inch thick. And I also know that the paper can go a little bit bigger than the actual easel. So what I'm going to try to do then is I'm going to try to use that information and put that together. And so if I need this length right here to be at least 8.5 inches, to be no more than 8.5 inches, then what I can do then is I can cut that in half. That's about 4.25. And if I add in the fact that I've got these 3/4 inch pieces right here, what I can do is I can decide how long I need this to be. So I need it to be a little bit less than 4.25 inches. And in particular, notice that I've got that these lengths or these widths on these pieces of paper or these pieces of wood are about 3/4 inch thick. And since I got 3 of them, I've really got 2.25 inches. Then I can kind of knock off some of that length as well. So what I'm going to try to do then is I'm going to try to get this to be about 3 3/8. Now, when you're working on these particular problems, you won't have to necessarily decide how big you want that to be. It'll be given to you. But if you're making something, you can decide how big it's going to be based on how big you want it to be. And so for me, I'm going to want this to be about 3 3/8 inches altogether. Again, I want the distance from the bottom of the easel, so where it actually lands, so this is where it's going to sit, the piece of paper. I want that, from that to the top, needs to be a little bit smaller than 11 inches, and so I think I'm going to go for 8.5 inches. So from here down to here, I have 8.5 inches. And now my ultimate goal is, what is that angle going to be? And I want to be able to figure this out. And so that's where the math actually comes into play. Because what I've really got right here is I've got a triangle. So this triangle looks like this. This triangle has a right angle, so it's 90 degrees. I know the length right here is 3 3/8. And I know the length right here is 8 1/2. So is there a way to figure out what this angle is? And it turns out that using mathematics, you can actually figure that out. Now, once I get that angle, that's going to help me make the cut. Now, the reason why it's going to help me make the cut is ultimately, and just so you kind of know, but I'm not going to focus on this for this particular class, ultimately, I need to know this angle right here, right? And in order to figure that angle out, I use the fact that this entire angle, so from here to here, is 90 degrees. And the angle that I'm going to try to find on this triangle would add up with that yellow angle that I just drew to make the 90 degrees, so I would just subtract what I get from 90 degrees. But I'm just going to focus primarily in this particular class on how you find the angles in triangles so that you could ultimately make things out of wood. So you've got some type of diagram, you know some information about the diagram, can you figure out certain angles that are going to help you when you're actually making something out of wood? All right, so let's see if we can actually do that. Okay, so it turns out that if I'm looking at a triangle, one of the coolest things about mathematics is that if I have a triangle and it is a right angled triangle, then if I was to pick an angle in here, and it doesn't matter which angle I pick, as long as I don't pick the 90-degree angle, so if I pick this one right here, and I'm going to call this alpha, which looks like a fish, but it's just, it's the Greek letter A, then for that angle, there are specific sides of the triangle that are, connected to it. So there is the adjacent side, there is the opposite side, and there is the hypotenuse side. So when I'm looking at that angle, the opposite side is on the opposite side of the triangle, the adjacent side is next to it or adjacent to it, and the hypotenuse is what we call the longest side of the triangle. Now in mathematics we have this thing called right angle trigonometry, and right angle trigonometry tells us that if I take the angle and I want to look at some ratios of sides, I can identify them using the trigonometric functions. So for example, if I talk about the sine of the angle alpha, what I'm doing is I'm saying that the sine of the angle is a ratio of two sides, or a fraction created from two sides, where I take one side divided by the other. Now, the sine in particular will always be the opposite side of the angle divided by the hypotenuse side of the triangle. The cosine of an angle will always be the adjacent side of the angle divided by the hypotenuse. And lastly, the tangent of the angle will always be the opposite side divided by the adjacent side. A lot of people like to remember this as SOHCAHTOA. In fact, I used to have a t-shirt that said Camp SOHCAHTOA on it. SOHCAHTOA is the idea that sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So why is this helpful when we're trying to figure out information in a triangle? If I know some information, then I can use this to actually determine either angles or lengths. So let me show you, for example, what types of information you could have in a diagram. Say that you know that this angle is 33 degrees. And say that you also know that this adjacent side is 5 inches. Then using the fact that you have the angle and you have the adjacent side, if you want to know what the opposite side is, so suppose that you're trying to figure that out because you have to measure it and cut it, then what you're going to do is you're going to recognize that you have the adjacent side, you want to know the opposite side, and you have the angle. Now the three of those things show up in one of these formulas, and that is the tangent formula. The opposite side, the adjacent side, and the angle. And what I can do then is I could take the tangent of 33 degrees, and I know for fact that that is the opposite, our question mark, or let's call it x, divided by the adjacent, which we know to be 5 inches. Now if I have a calculator, and in fact I do have a calculator, I can punch in tangent of 33 degrees, and I get 0.6494 is equal to x over 5. And then I can solve this equation by multiplying by 5 on both sides. And what I end up getting is I get 3.247. So this tells me that x, 3.247, is equal to x. So what does that mean? Well, first of all, my 33 degrees is not actually drawn to correct scale because 33 degrees is less than 45 degrees. This side length would have to be 3.247 inches. So my drawing is not necessarily great, but the information that I'm getting from it is perfect, because now if I need to cut a piece of wood to make into this, that fits into this triangle, I just need to make sure that's 3.247 inches. This is not the only thing that I can do. I can use sine, cosine, and tangent for virtually anything with triangles. And what I'm going to always do is I'm always going to pick when I have two pieces of information, I'm trying to find a third. I identify those pieces of information and then use the corresponding formula. So let's see if we can go back to our original question, which is that I'm trying to figure out, suppose that I'm trying to figure out the information that we need for our easel, then I could take that easel triangle that I had and I can see if I can figure out that missing piece. So remember, the missing piece was we were looking for this angle right here. And we know that this needs to be 3 3/8. Now, if I take 3 divided by 8 to get the 3/8 in decimal, it's 3.375. And we know that we want this to be 8.5, so 8.5. Okay, so then what do I have? I have, for this angle, this is the opposite side. For this angle, this is the adjacent side. And so then I can try to use that piece of information to find the angle. So in other words, what I have is I know that the tangent of the angle, let's call it alpha, I know that the tangent of alpha is equal to the opposite, 3.375, divided by the adjacent, 8.5. Now 3.375 divided by 8.5 gives me 0.397. And that's what the tangent of the angle is. Now that's not what the angle is, it's what the tangent of the angle is. So there's a special button on your calculator that tells you how to go go basically backwards. And that button is the tangent inverse function. So if you know the tangent and you want to find the angle, what you're going to do is you're going to get the angle by taking what's called the tangent inverse. And that's the button on your calculator. So you take the tangent inverse of 0.397. Anytime you have tangent of angle equals number, or sine of the angle equals the number, or cosine of the angle equals the number, you always just take the inverse of that function. And technically what you did was you took the tangent inverse of the tangent, and that gave you back the angle. And then that's going to give you the tangent inverse of 3.397. Before I move forward though, let me just remind you, one of the things you want to make sure you do, since we're working with angles and degrees, is you do want to take your calculator and make sure that you're in degrees. And for me, that's the button that looks like the DRG. And if I click on it, it has me choose between degrees, radians, which looks like rad, and gradient, which looks like GRD. So I want to make sure that I'm in degrees. Once I'm in degrees, then I can take my second tangent, which is my tangent inverse button, and I can point in 0.397, and then I hit enter, and I get 21.7, which is about 20. If I round it to the nearest degree, it's 22 degrees. But okay, so alpha is approximately 21.7 degrees. And of course, when I go to cut that, it's going to be about 22 degrees because I can't quite, there's not a spot on my saw where I can choose 21.7 degrees. All right, so now I know what to cut that angle at. And so then the biggest thing now is basically anytime I have a triangle, If I identify the angles that I have in there, then once I identify the angles and all that good stuff, then I can identify which function I want to use. So let me just show you one more time really quickly. If I have a triangle with a bunch of angles and I want to figure out what function to use, so if I have this triangle right here, and suppose it's a right triangle, and suppose that I didn't know what this angle is, maybe it actually looks like about 51 degrees, and suppose that I know that this needs to be 13 inches, and I want to figure out this side. What I'm going to do then is I'm going to identify for the 51 degrees, this is always the hypotenuse, it's always the longest length. This one to the 51 degrees is the opposite side. The one that uses the opposite side in the hypotenuse is the sine. So I get the sine of 51 degrees is equal to the opposite, which I do not know, over the hypotenuse, which I know is 13 inches. Now I can take the sine of 51 degrees. Sine of 51 degrees gives me 0.777. So 0.777 is equal to the opposite. Let's call that x, since we don't know what it is, over 13. Now I multiply by 13 on both sides, and I end up getting 10.1. So 10.1 is equal to x. And so now I know that the opposite side, that piece of wood, needs to be cut to 10.1 inches. And it's the same every single time. I identify what information I know, and then I use one of those 3 trigonometric functions or its inverses to figure out what I'm looking for. So now let's go back out to the wood shop and see if we were able to make that easel the way that we wanted to. Here we are back at the tool shop, and I've taken the liberty of making a few cuts. Now I've got my easel here, and the question is, did the mathematics really make it work out? So as you can see, the easel sits pretty nicely, but the question is, did I get the measurements that I want? Alright, so as I said before, we've got a triangle in this easel, and that triangle that I'm talking about is this triangle created right here. Now we use the information that we'd like to have a piece of paper sitting on here that's about 8.5 by 11. And the paper can go a little bit above here, and it needs to make sure that it doesn't go much further inside of here. So this piece of wood right here I do know is 8.5 inches long. The question is, the triangle that I used to base all those measurements off, does it match what it was supposed to match? Because my cuts are already made and the easel is already made. So just one last piece of work here then is just to make sure that we've got this all right. So right here, when I measure it, I get about 3 3/8 of an inch. So that looks pretty good. Right here on this leg that I measure, that I use for my piece of information, I get about 8.5 inches. So that's pretty close to what I wanted. And last but not least, and I already did the cut, so I already know the angle, but let's just double check it anyways. So this angle in the triangle, I'm getting about 22 degrees. So using math, I was able to get an easel the proper size that I want. And so now I can actually get the piece of paper that I want to fit up here to fit. And the rest of my day I plan on making more easels of varying sizes using mathematics, because I'm going to be going with my wife in a few weeks here to an art fair, and we want to have a display for her art. So thank you for joining me on this old math class, and until next time.